Ladies and gentlemen, welcome everybody to this first session on research results in the track of the recent results track. My name is Lajos Bálint. I am from Hungary, from HUNGARNET, the Hungarian Academic and Research Network community, and it is my distinct pleasure to serve as chair to this session today afternoon. Maybe some of you remember that the idea of organizing sessions composed of short papers about recent results did start about 5 or 6 years ago, and there were some serious debates at that time if these kinds of late submissions are worthwhile to invite or not. But since then, it really did prove to be very important and significant in the history of the Terena networking conferences. This year, we received, as you have heard yesterday from Stefano Trampi, the chair of the program committee, we received more than 20 submissions to this recent results track, and 8 of them have been selected for inclusion into the program. The coverage of these 8 contributions is quite impressive. There are 8 countries represented by the authors, and the topics cover the fields from optical networking and wave division multiplexing to security issues, from active networks and network management to applications just like video conferencing. So hopefully we will have 2 interesting and attractive sessions today and tomorrow afternoon with the session called 7A. It will start at 3:30 tomorrow, as I remember, or 4 o'clock. So welcome everybody today, and I hope I will meet you tomorrow afternoon as well. The first presentation today will be provided by Fotis Karayannis. This presentation and all the others will take about 20 minutes because the complete amount of time for us is 90 minutes for this session, and we probably will need some room for comments and questions. So please, dear authors, keep this about 20 minutes time limitation. Fotis is from Greece, and he is presenting a contribution by an international team because among the authors you find Greek and Spanish authors as well. Fotis himself is working both for the Greek Academic Network organization and OTE, the Greek national telecom provider. More or less, actually, maybe he will explain a bit more.
Actually, it's a subsidiary of OTE.
Oh, I see.
It's OTE Consulting.
It's
a different company, but it's a subsidiary of OTE.
Thank you. Thank you. So, Fotis is talking about a management architecture for IP over WDM integration. Fotis.
Thank you, Lajos. Good afternoon. My name is Fotis Karayannis, and I will present to you the paper entitled A Management Architecture for IP over WDM Integration. This paper has been produced in the framework of the IST okay now? So this paper has been produced.
Just a minute, Fotis. If we use this microphone, please switch off your mobile or your cell phones if you have any with you, because there might be some interference. Thank you.
Okay. So this paper has been produced in the IST framework by the Winman project. The authors are Lampros, Raptis and Chatzilias from National Technical University of Athens, Professor Joan Serrat from Politecnica de Catalunya, and Dimitris Chronis from OTE, it's the Hellenic Telecommunications organization. So the rationale for this project actually, and the paper, as you all know, the convergence of voice, data and multimedia services over a unique IP-based network, the requirements of the augmented requirements of bandwidth and in parallel for QoS and differentiated services, the requirements of easy service deployment monitored by SLAs, the IP transport service which dominates and which will dominate the data networks, but also its limitations to provide QoS, the MPLS framework which promises to support traffic engineering, quality of service in cooperation with other architectures and VPNs, and the maturity of the WDM technology which can transfer a huge amount of data to customers. Additional rationale for this project, the need for end-to-end connectivity with easy setup and maintenance and augmented bandwidth and QoS, the combination of IP and WDM with or without intermediate layers, but now without ATM and SDH, for example, seems promising, but there are two completely different ways of providing these technologies. In the IP domain, it's the control plane approach, the internet style using signaling, and in the WDM domain, it's the telecom style approach using management functions. Note that in this paper, a domain is not an administrative domain, rather it's a technological domain, that is IP, WDM, and so on. So the current trends in IP WDM integration by IETF, it's the MP Lambda S framework, which extends the MPLS framework in the optical domain, and needs synergy with appropriate routing protocols, extensions like IIS and OSPF. The Optical Interworking Forum and the Optical Domain Service Interconnect are in the process of defining ATM-like UNI signaling protocols for and interfaces for IP, for a client layer over WDM, for the interaction between a client layer such as IP or other, and network to network interface for the WDM to WDM interaction, that is interaction between optical network elements or optical subnetworks. Also, all the above and ITUT have proposed some new frameworks which are now being standardized, being developed, which are the GASON, which stands for Automatically Switched Optical Networks, and GASTN, which stands for Automatically Switched Transport Network. The ASON architecture, besides the UNI and NNI, also provides a network management interface for permanent optical channels. This is similar to ATM somehow, which is the case for the Winman project, as I will say later. So some problems with these trends. As far as technical issues are concerned, they are not mature. Some vendors have done some early implementation, but there are still interoperability issues. As far as the business model, the incumbent operators want to make use of their investments in intermediate layer legacy networks like ATM and SDH, which don't fit in this view. The current equipment do not support such new signaling. The competitive ISPs could deploy such an automatic switched IP over optical network, but still they prefer more cost-effective solutions like leasing lambdas. And dark fiber and condominium fiber and lambdas are not yet the case, at least for Europe. Maybe for Canada and the States it's more mature anyway. And just recent announcements from Cisco that suspended their IP and WDM integrated element, the ONS 5900 series equipment, which supported the wavelength routing protocol, which is their implementation. So what is Winman doing? The idea adopted is that instead of extending the internet control approach using signaling down to the optical layer, it extends the telecom style approach using management functions and management means to the IP layer with a synergy of MPLS, which MPLS resembles a connection-oriented network. So this is the main idea. So the idea is to integrate, in other words, the IP and WDM, and it's extensible to other layers as well, under a common interdomain. Interdomain stands for intertechnology domain management system to provide end-to-end transport services using MPLS. So some pros of this solution: the telemanagement forum is in the process also of defining standards for this interdomain management interfaces. The solution is, as far as the business model is concerned, is extensible to a multi-vendor and multi-technology environment, including the ATM and SDH legacy systems, which can easily interface to the interdomain management system through the appropriate adaptation and the corresponding interface. Competitive ISPs could deploy it easily, even if leasing lambdas, but they need to access the management system of the optical layer, either read-only for something like fault management or to have full access to do everything. And of course vendors push to have first single domain, of course interdomain, intertechnology domain management systems, then the control plane signaling protocols, which are immature and their future is not definite. So Winman goals, it's the integrated network management. Winman is an integrated network management solution capable of managing end-to-end IP connectivity derived from SLAs. The dissemination of the Winman results to the international society and the exploitation of the results in product and service development is other goals of Winman. So some information about the project. It started on July 1st, 2000. The duration is 33 months. The resources are 842 person months. And the partners are the operators from Spanish Telefonica ID, it's the research lab of Telefonica, the Portugal Telecom in Vacao, the research lab from Portugal Telecom, OTE from Greece, and OTE Consulting. From universities, it's the UCL from United Kingdom, National Technical University of Athens, and University Politecnica de Catalunya from Spain. And from the industry, it's Solution Technologies, who pushes also for this solution, for this inter-domain management system. TTI Telecom from Israel, they are a software company, mainly producing management for telecommunication operators. And Telemedia, which is part of the Lucent family. So the target architecture, it's the inter-domain management system in the middle, which is a single point of access for all management functions and for all technology domains, for different technologies, and it's easy to add new services. So of course the drawbacks of the lack of the IMMS, It's complex, of course, and inefficient because each of the management functions have to have interfaces for all the different technologies. The scope of WINMAN, the development of the inter-technology NMS, and additional the IP and WDM NMSs, which will be developed from scratch, as well as a single connection model, a technology-neutral connection model with uniform QS perception and uniform fault and performance representation. The standards that will be based upon is ITU's G805 and G852 connection models, the TMF Telemanagement Forum Telecommunication Operation Map. It's a framework for providing services and off-the-shelf services quickly to the market and so on. And the interfaces by Telemanagement Forum, which are under development right now, it's the Multi-Technology Network Management, MTNM, version 2.0, and the CASMIM. CASMIM stands for Connection and Service Management Information Model, which will be produced by Catalyst Telemanagement Forum project. And of course MPLS, which should be supported in the IP layer. The functional model, this is the WINMAN solution in this rectangular. WINMAN will develop this interdomain NMS and the IP and WDM NMSs. So these two layers will not be implemented, but these interfaces will be generic enough, something like technology neutral as much as possible, of course, to support different kind of technologies. The boundaries of the system to the northbound reference point, it's the service management actors like VPN service providers or other or ISPs or so or whatever. And the southbound, they are the element management layers of the TMN architecture, and of course there is also an interface to the WINMAN operator with a graphical user interface. So the physical model, as I told you, these systems will not be implemented. So the interdomain management system will have functionality for configuration management, performance management, and fault management. The GUI for the operator, the domain managers, the technology domain managers for IP and WDM, which will interface to the legacy systems, to the element layer or to the network layer with a proper adaptation. And on top, WINMAN is not doing more, just some test components. We won't develop a complete system, but we will provide an open interface so that other projects who support VPN functionality or other means could interface to our system. So the technical approach, the definition of the inter-domain management architecture, and consider connectivity services based on IP and MPLS. The implementation of network management systems, as I said, we will develop the interdomain NMS, the WDM NMS and the IP NMS from scratch. And actually the way that we are doing it is we provide a generic NMS with some basic functionality, and then we will adapt to the different technologies after we build this technology neutral prototype. And of course we are in the process of selecting testbeds right now, and there are nice testbeds in Lucent Lab in Greece, where ITs will deploy a WDM network quite soon, and in other places like in Portugal, in Spain and so on. The main characteristics of the systems: support for multi-vendor, multi-domain management, focus on IP over WDM, open management architecture, policy-based driven management, management functions and applications. As far as configuration management, to establish the functionality will be to establish end-to-end connectivity services, present end-to-end view of the services through the GUIs and so on, auto-discovery of network elements. In the area of fault management, the alarm reporting from the different domain network managers, the alarm correlation, isolation and localization of faults, and as far as performance management, the performance monitoring and network congestion and hotspots in the network, and of course the interaction between these, fault, performance and configuration, for survivability. The design and implementation method, we are using the Unified Modeling Language, the UML, and some kind of the RAP, the Rational Unified Process, some subset, let's say, we are using. First capturing the requirements, then designing some, writing use cases on different levels, summary, user and atomic level we call them. Then the scenarios for sunny weather and error handling, message sequences and message sequence charts for data flow. Then we have some components-based architectures to build components and blocks and interfaces between them, and the specification of external interfaces. The tools that we are using, actually we are using the rational rows and part of its tools, because the rational rows is a whole suite with different products, and the distributed component model with Corba components or enterprise Java Beans components. So just an example of the domain model view having the MPLS and optical layers. This is based on the G805 and the G852 connection models. It's a connection-oriented model. And conclusions. It's a new challenging approach for IP WDM integration based on the management plane. We will study, if we have resources, also the interaction with the control plane as the ASON architecture proposes, but first of all we will develop the management plane solution for IP and WDM only. WINMAN solution is a unified management architecture for different technology domains, and it's a short and medium term or even long term if the other frameworks like the ASON are not adopted, to coexist with the control-based approaches, partly depending on the WINMAN solution evaluation. So for more information, this is the WINMAN website, www.winman.org. So
thank you very much, Fotis. You should note that all the slides are available and accessible on the Terana website under the TNC, the Networking Conference Proceedings link. As I have heard, there are some improvements in these slides, so Fotis will ask Carol to put the new version onto the web within a few days. Thanks again, and let me ask if there are one or two short questions or comments, or we may leave the questions and comments to the end of the session. Anybody at this moment? If not, thank you again. And let me ask David Harmelin from DANTE Limited. DANTE is the European service provider for the academic and research networking community. to present his contribution entitled DOS Attacks on Transit Networks. David.
Good afternoon. Well, the presentation is quite long, so I might go fast on a few slides, but as Lajos explained, the slides are available on the website, and I will be also available for the rest of the conference if you want to speak about them. Denial of service attacks on transit networks. Transit networks, because they interconnect usually a lot of other networks or end sites, are more likely to carry such denial of service, or which are more commonly known as DOS attacks on their networks than, for example, end sites. So, because we have a bit of experience on 10155 on how to detect them, we thought it may be a good idea to share our experience with this community. Just very quickly on DANTE. DANTE is a company that plans, builds and manages advanced network services for the European research community. The current network is 10155 and it connects 30 national research network, and we have another network coming up called Joan, which will be a gigabit network with speeds up to 10 gigabit per second on the network. DANTE is also active in testing and evaluating emerging technologies like IPv6 and PLS, DiffServ and flow monitoring in the context of the TF-NGN task forces. And DANTE also operates a computer emergency response team called DANTE, and I'm also a member of DANTE. Well, this is our current backbone, if you can see it. Yeah. I don't want to spend too much time on this. If you have questions, you can go to the DANTE stand, which is just outside this room on the right. DOS attack. This is a general definition. A DOS attack is an attack on a network or computer which primary aim is to disrupt access to a given service. Now, in the rest of this presentation, I will only speak about networked, flood-based DOS attacks. Networked means attacks over the networks or over the network, because there are other types of DOS attacks which can be local to a given machine. And flood-based, that's also because there are network-based attacks which can be made with only one packet. I remember back a few years ago there was a ping of death attack, which was by sending only one packet to a given machine, it will crash the stack of the machine. So I will not speak about those attacks in this presentation. This is a typical example of a networked, flood-based DOS attack. All the hosts in this drawing are usually compromised hosts by some crackers, by the attacker maybe. And in this case, the attacker, well, except the attacker and the victim machine, which are not compromised. And in this case, the attacker will send one command to the master machine, which itself will send various commands to the handlers, which are responsible of handling the hosts in the network N1, N2, and 3, for example. And those hosts will then start to flood the network towards the end machine in order that the services offered by the end machine, which can be a web server, for instance, or an SQL server, or an IRC server very often, is so that those services are unreachable from the rest of the network. Now, in this case, as you can see, the transit network is where all the traffic is first aggregated, and this is where it can be useful to put some tools that will detect when such attacks occur, so that the transit network operator is able to reduce the amount of DOS attack crossing its network. Why should we care about DOS attacks? DOS attacks add to the overall cost. A lot of times, many network operators do not notice when such attacks occur. They will just think that there is an outage when a router restarts or when a circuit is completely filled. And in this case, this network operator will have to upgrade its circuits and its routers in order to accommodate with the extra traffic. Also, there may only be one target, like in my previous example, but many outages. In this case, for example, maybe a router will restart on the transit network, and all the customers of the transit network, not only N1, N2, N3, and N, but maybe the transit network has other customers. All the customers will be affected by this outage. And finally, there is no quick fix in sight, and the only way at the moment to reduce the effect of DOS attacks is to have a better cooperation between ISPs and between peers in particular, so that when an attack is reported, other ISPs which carry the attack can quickly trace it and find the source of the attack, or the sources in some cases. Are you affected by DOS attacks? Everybody running or using IP networks or services is. Maybe it will be your upstream which will suffer outages, in which case you will be also affected by loss of connectivity in some cases. DOS attacks are rarely reported in the media. That's for obvious public relations reasons. Companies don't want their customers or their competitors to know about the fact that they are being targeted in some cases. Many organizations do not notice when they are affected. They just think they have an outage and they try to find out what's going wrong, and when the attack ends, the outage is over, but they don't really understand where the outage came from. And also in some cases, the technical staff may be aware of the problem, but management may not be notified, maybe because the technical staff thinks that nothing can be done about it, and the best thing to do is to wait for the attack to be over. At DANTE we started seeing a lot of regular attacks in 1999, and we had a few attempts at coding a few tools, and at the end of 2000 we enabled a tool on our network which was developed by DANTE and which was based on analyzing sampled flow data. And nowadays DANTE relies on this tool heavily to reduce the amount of DOS attacks. So this is the principle, how it works, how the tool works. Each box is basically a point of presence, and in every pop we will have at least one router. This router exports netflow data to a local workstation on a continuous basis. Now there's also a central server that will, every 15 minutes, let's say, the central server will query the workstations in the local POPs and will ask for a few flows for a small period of time. And it will sample, let's say, about 1 out of 100 flows. Now those flows will be inserted in a database on the central server. We will run statistics against, for example, the destination IPs. And if we find that a given threshold is reached, then an alarm will be issued. This alarm is being sent at the moment to the DANTE team, and then the DANTE team checks that the alarm is a real DOS attack. And after it is checked, then maybe a DANTE ticket will be issued and sent to the peers of the 10155 network. And we also log all the attacks now for statistical purposes. Now this is exactly what I explained with a few values. I don't want to repeat myself, so if you want to have a look at the values, you can download them from the Terena website. Now to the results. We've been running the tool on 4 core routers on the 10155 network since the end of last year. We enabled logging of statistics since March of this year. We found out that configuring the tool is usually a compromise between accuracy and the detection effectiveness, where accuracy is the number of confirmed attacks compared to the number of alarms raised. And with the current parameters we use, we have 98%. That means that out of 2 alarms raised, those are, well, out of 100 alarms raised, there are 2 false alarms. And detection effectiveness is the lowest amount of packets per second from which we will raise an alarm. So that basically means that we could improve the accuracy percentage, but maybe we will only detect attacks which are above 200 packets per second. So this is a compromise. We are logging an average of 34 different attacks per day, with up to 5 or 6 concurrent DOS attacks. And we are also polling the routers 96 times per day. So if you calculate, we are polling the routers every 15 minutes. (90% of the C-class attacks are 90% of the attacks are what we call C-class attacks, and I will explain in the next slide what we mean by that. And that's an interesting result since C-class attacks are relatively easy to trace. And also 75% of the attacks are 40 bytes and TCP packets. Now that's what we call a C-class attack. Well, in this case there is one workstation 1, WS1, which generates all the traffic, and this workstation 1 will usually be a compromised host, and it is flooding the WS workstation, which is the victim in this scenario. And although the workstation 1 only has one IP address configured, all the packets generated by the tool appear as if they are coming from the range of IP address at the bottom of the slide. Now, this is for obvious reasons that the attacker does not want the source to be found by the N1 network operator. And back a few years ago, the software would have generated completely random source IP addresses, but nowadays you will have the router 2 or router 1 which may filter packets with and will drop packets with a source IP address that does not belong to the network N1. So this behavior is coded by default in many denial of service tools. Now the advantage, if you are sitting on the transit network and looking at the packet going through, it is very easy to say this DOS attack is coming from network N1, because you just have to do a lookup on the address range on the ArrayDB database, for instance. Durations of attacks. As you can see, more than half of the attacks last less than 15 minutes. So because DOS attacks do not leave any trace on the network usually, or any trace on the victim, it requires a very fast inter-domain tracing to find the real source of the attacks. Traffic generated. As you can see, there is not a lot of traffic in terms of megabits per second. And as I said also earlier, most of the attacks are 40 bytes packets. Now the aim of DOS attacks nowadays is to saturate the forwarding capacity of fast Ethernet cards usually. There's a few fast Ethernet cards out there that, although they are supposed to be able to handle 100 megabits per second, cannot handle more than 300 packets per second, for example. So by generating even less than 1 megabit per second but very small packets, it is quite easy to crash a machine or a server at the other end. Now, limitations of this method. Obviously, you need to be able to run NetFlow on the routers. There's a few routers that cannot run NetFlow, either because you don't have the correct software or because you have an interface that cannot run NetFlow at the same time with access list, or maybe the router vendor does not support NetFlow. Also, this method only helps detecting networked flood-based DOS attacks. It will not detect attacks which are based on sending one packet, for example. And it does not detect all networked flood-based DOS attacks because we only poll the router every 15 minutes at the moment. And also another limitation, which is not only a limitation of this method, but detection helps, but there's a further need for cooperation between ISPs, and that's what is really blocking at the moment, because sometimes we are seeing a DOS attack on 10.155 and we are reporting the DOS attack, and after 1 day the DOS attack is still ongoing. Other approaches, no detection. If you have enough money to buy new circuits and new equipment, why not? To accommodate the extra traffic. Human detection, having somebody sitting there 24 hours per day and looking at the counters, and well, that's a solution. Another solution is having a program that will monitor CPU load and traffic counters. Now that's also interesting. However, the disadvantage I find in this solution is that if you're, for example, logging attacks during the night and you come back in the morning and see you had a big outage, you will only see the force of the attack and what was the result of the attack, but you will not be able to say where the attack was coming from the internet and where it was going to. You may only say it has entered my network from this point and has left my network from this other point. The IETF is working on a new ICMP message called iTrace. Now this is still work in progress, and I suggest if you're interested in this topic you can go to their website. Passive monitoring, there's a few products out there that are based on a splitter which sends an optical splitter which diverts the traffic to a box that is sitting next to the router. Now, I'm not sure that it is possible that those products run at speeds like 10 gigabits or 2.5. I think they mostly run at 155 megabits per second. And other flow monitoring approaches. Now, if you have to remember one slide, I would like it to be this one. Who should help and how? IP network operators. We think that if more IP network operators would implement the same kind of tools that we have implemented on the 10.155 network, it will be a lot easier to find the sources and to close the sources of DOS attacks and find the compromised host, a lot quicker. And also, better cooperation between third teams, as I've already said, is important, and this could be implemented maybe in the SLAs. At the end sites level, prevention is important. It could be done by rate limiting various types of packets which are known to be mostly DOS packets. It could be done by better working on not leaving any spoofed traffic, not having any spoofed traffic leaving the network. Also at the end site level, N-site should be able to trace when DOS traffic sources are reported, because very often we have reported sources and 6 months later the sources still exist. And finally, I want to mention that DANTE is giving away the in-house software that we have developed, that have produced the statistics you've seen before. And all we are asking for in return is a license agreement to be signed. And the main terms of the license are: it is a free software. You will not get a lot of support with it. If you do any debugging, if you find any bugs on the software, you should let DANTE know about it. And I think that's the main terms of the license, basically. And that's the end of my presentation.
Thank you very much, David. Thank you. This was really a contribution of recent results, because your experimental data are coming from March and April, as I understand. So if you have any questions or comments, yes, there are two hands. Yes, please.
I was wondering, you gave some some numbers for your probability of detection, probability of false alarm, right? You mentioned 2% false alarm, and I don't know what you said about probability of detection, but let's assume it's high. But do you have some way of developing what is known as the ground truth? How do you know that something? Do you have some way of developing the ground truth? That is, I'm using target recognition terminology, which is basically what led to the ROC curves that you are using. Do you have some idea of how you can certify that something is a denial of service attack?
No, that's quite difficult. The way we do it now is that we contact our peers and we ask them, are you victim of, are you feeling this attack? If they tell us, we are contacting our peers to see if they can confirm that this is an attack. That's what we are doing at the moment. Certifying that what has been logged as an attack is an attack without asking what we consider is the victim is a bit difficult. I don't see how we could do it.
How can you cope with specific servers like transparent proxies or proxy web servers, where all of them are a point of source of traffic? So that means that you have a lot of traffic going to them.
Yes, we have had at the beginning a few false alarms with DNS servers, that is DNS root servers that is in Stockholm, I think, and it was triggering a few false alarms. Now there are ways to there are two possibilities: either to change the parameters and say, okay, I was detecting every denial of service attack that was above 100 packets per second. Now I will detect only denial of service above 200 packets per second. That's one possibility when false alarms start getting triggered. Another possibility is to maintain a list of known IP addresses, like DNS root servers, that trigger false alarms.
Thank you. One last short question, please.
Thank you. Can we go back to your last slide, please? I think the tool you just described helps tracking DOS attacks very nicely, but I do think that a lot more emphasis should be put on prevention of DOS attacks. And the prevention now is on your bullet with end sites. And I think IP network operators can do a lot there too, by making sure that from their network no spoof packets are entering, for instance, 10155. And that is by using the very commonly available feature of, for instance, Cisco routers that is called unicast RPF check. So can I have a raise of hands here? Who works for an NRM? Please keep your hand up if you're using unicast RPF checking on each and every customer port.
This doesn't have the last if you're a transit provider, you can't do it now.
Of course, if you're a transit provider, but if you're serving end customers, you can do it on your end customer lines. And if everybody does that, DOS attacks would be gone. At least non-traceable or not easily traceable DOS attacks would be gone.
Thank you. David, some reflection?
Yes, I just want to comment that I don't know RPF unicast checks very well. I've seen the feature, but we've never enabled it. And I'm not sure it works if a network is multi-homed.
So, thank you very much again. Thank you, David. And now let me call Stephen Bush to the floor, who is from General Electric Corporate Research and Development, and Steve will talk about active virtual network management prediction. Steve.
Thank you. Okay, my name is Steve Bush. I'm from General Electric from United States. This work came out of a DARPA-funded project. Let me just start by saying one of the things that's been going on in the United States among researchers, I think, is there's a growing body of people who want to start looking beyond IP. So, I mean, for this talk, just try to erase IP from your minds for a little bit, especially Steve Deering's talk, and try to think a little bit fresh or open-mindedly about this. Also, we are getting pushed, from government agencies in the United States to think longer term, think beyond IP, think new thoughts, new ideas. So that's what this is about. So this is a little bit different, I think, than a lot of the stuff you've been seeing. Amit Kulkarni worked with me at General Electric to put together this demo that I'll be showing, and then it was tested, and our collaborators at NIST use this for a very particular application for, again, denial of service attacks inside of an active network, which is active networks add a new dimension to trying to, it adds a lot more complexity, and it's a lot more difficult to manage. Okay, so what are some of the benefits of active networks? First of all, I'm talking about an active network built on a framework, which I'll describe on the next slide. But there's a framework which defines a node OS, execution environments, and then packets which carry code which can be executed on intermediate network devices, such as routers, switches, bridges, hubs, those types of devices that we think of today. So that, you have faster hardware that's more fully utilized because you're now allowed to start executing code inside of the network. And in fact, there's no longer a dichotomy between data and computation. Computation and data are both functions of the network, and both can be used to support the other. It enables more flexible networking, obviously. The protocol is decoupled from the transport mechanism because the protocol can travel with the packet itself. Obviously, as long as this common framework is agreed upon, it minimizes global agreement and overhead that's required. In other words, it doesn't take 50 years to introduce IPv6 or something like that. I mean, you put it inside, you program it inside of your packet. Enables on-the-fly experimentation, obviously, and extremely rapid deployment of new services. Okay, this is the slide which shows the framework which I'm talking about. You have some hardware mechanism for what we would think of today as an intermediate network device. There's a node operating system for that device. And then on top of that, if I press the right button here, there's the execution environments. Now, there can be multiple types of execution environments. Much of the work done in active networking up to this point has been done in Java. However, there's C++, Camel, Plan, various other active execution environments. So on top of that resides active applications. And we have active audio applications, and an AVNMP, which I'm going to describe, is a active management application, which also resides up here. So you can think of these active packets coming into an execution environment, coming up through the node OS, and then the node OS looks at what type of packet it is. If it's a Java packet, it gets sent to a Java execution environment, such as ANTS or Magician, or there are a variety of different types of execution environments. And then it gets executed in there, and then if the active application decides to forward a new packet on, a new packet would get forwarded on. So you can see that the execution environment is sort of like a Unix shell. I mean, it takes a packet which has code in and executes it. All right. Okay, there's something called the Active Network Encapsulation Protocol, which is even though it looks big here, it's actually just a very thin header on top of the payload. The payload is the executable program, which, again, I usually think of Java because I've been using the Magician execution environment. But the main thing is that the bulk of the packet is the payload. There's a type ID which identifies the particular application so that the node OS can route it up to the right execution environment. Okay, so if that's kind of the background of the environment that we're working in, with data and computation both intermingled. Now, what could we do with this? Well, one thing that we've done is, you can imagine that this is a very complex environment to manage now, because packets can take arbitrary amounts of time to compute. So what we wanted to do is see, could we use this complexity, fold it back on itself, and use the extra power to help manage the network itself. So what we wanted to do was have a self-predictive system. So what we were going to do is inject models of the system into the system so that the system can be self-predictive. So it enables management of more complex systems, such as these active networks. It shows signs of self-healing and self-management. If you think of SNMP or various types of management mechanisms today, it's often polling-based. And we'd want to be able to set if we know something about how the system is operating, we could set a more optimal polling interval. Faults would be generated as alarms before they actually occur. So the system can be fixed before it's impacted. You have time to perform dynamic optimization of repair parts, service, and solution entities, and helps with resource planning. And also, with this thing, you can do what-if scenarios as part of the network. And it becomes very fault-tolerant, because these components operating inside the network are in the form of active packets, which can hop from node to node when they see that there is an impending failure. So if you'd imagine, again, I don't know how many people are in network management here, but if you think of SNMP, where you query devices as you travel through the network, well, again, with active networks, you can now have clients which actually are inside of packets which are traveling through the network. So if you were to query devices today, you'd get what's the state of that device at the current time t. But with this predictive mechanism injected into the network, you can now get what's the time, not only at time t, but at sometime into the future. So so you can get the future state of the system. And the way we've implemented it is through a time warp-based simulation technique. So we have, if this is the real network down here, we try to make optimal use of both space and time, because these, what we're calling logical processes, are residing on each node, running forward in time, and then there's a time warp rollback type mechanism to keep them in sync, because each one can work as far ahead in time as he can locally, but he may get out of sync with other messages that are arriving and have to roll back. This DP is a driving process which injects the virtual messages into the system. So what you have is two things running at the same time. The actual system, which is actually sending data through it, data or programs, and then a mirror image of that running forward in time, which can then be queried as I show up here, so that you can see what the state of the system will be in the future. Okay, we actually implemented this and ran it. We had an active audio application on a variety of systems. We wanted to show the heterogeneity. You know, there was a fast, slow, and medium speed processors in the intermediate nodes of the network. The Magician was the execution environment used. It's a Java-based execution environment. There's an SNMP MIB where the data is stored. So there's an active audio application running through the system. Then there's this logical process from AVNMP injected in the system. And again, this is the part that's running forward in time. So the idea is you can send in generic models. For example, I could send in a routing model which models how this thing might forward packets, or a CPU model which shows the CPU utilization for a particular application. And this is the part that NIST, the National Institute of Standards and Technology at the United States, had worked on. So you can, again, you could imagine expanding this to many other types of models which could be injected into the network. So this is the basic architecture right here. This is just a sample graph. Don't really pay attention to the actual values, but the point is that you have wall clock, which is the real time, and you have local virtual time on a particular node. And local virtual time should be running forward faster than the wall clock time. In this case, it was measuring load, so that you could be seeing the load in the future. And then there's this rollback mechanism, so that it's, you know, it would be rolling back to self-correct. Now there are several trade-offs here. For example, prediction error. Obviously, the further out you predict, the more likely you are to have error. On the other hand, you can set a tolerance, and you can say that as long as you're within a specified tolerance, a specified amount of error, you'll keep moving forward. You'll let the simulation keep going forward, even though it's not predicting perfectly accurately. However, you can tighten that tolerance, and when you tighten it, the tighter you make it, the larger the chance there is of rollbacks. So here we tighten the demand for accuracy, and the out-of-tolerance messages rose accordingly. And that also brought down the distance that we could see forward in time. So there are a bunch of trade-offs. And that, of course, if you measure speed up as the speed that the total virtual system is moving versus the actual system, it brought down the speed. So if you can sacrifice, well, you can have lots of error and get better performance and further look ahead, but if you want greater accuracy, you have to give up some things. This just shows the general idea. I won't go through this in gruesome detail, but here's the actual process, the physical process. Virtual messages are coming in, and real messages. Real messages go to the real process. Virtual messages, which are forward in time, or ahead of time, real time, go into the simulator, then both go out. Anti-messages can be sent following the basic time warp mechanism to keep everything in sync. So this is the models which get injected over here, and then this whole thing represents a logical process sitting on an active node. And the state cache inside the model is what gets polled periodically via SNMP, so that you can see what its future values will be. Okay, so again, we use CPU models and load models as active applications. Now, what NIST was concerned about was building CPU usage models, because they were concerned about stopping malicious packets. Because with active networks, especially, they're starting to catch on pretty rapidly. And the idea is people are fearful, though, of the fact that these packets, it would be very easy to have denial of service, because people could code packets which use up all the device's CPU. So we need to be able to accurately benchmark packet performance and kill the packet if it's either maliciously using up too much CPU or a fault in coding. So they worked hard to develop a benchmark. So they were experimenting with different types of models for benchmarking and stopping malicious packets inside of an active network. And so we were testing their models using our AVNMP system. So what they did is just put a basic time. They were comparing basic time to live on every packet. So we could take the active audio application and say that it has a fixed time to live. The problem is, obviously it could kill packets on slow machines when they shouldn't be, and it could let malicious packets go on fast processors when they should have been when they should have been killed earlier. But what we did show here is this is with the TTL, this is with a more accurate NIST prediction, CPU utilization prediction mechanism. And you can see that the number of rollbacks went down. The point being that the AVNMP system, with the better CPU prediction model, didn't have to roll back as often enough, so it could predict even farther out into the future. So they not only could stop malicious packets, but they helped our AVNMP system predict further into the future and more efficiently. So what we did was demonstrate the power of AVNMP as an active application for managing an active network, including CPU, and showed some of the trade-offs, which I showed you previously. Demonstrated that we are able to, the people at NIST are the ones you should contact if you have specific questions about how they modeled CPU usage, but they are doing a type of benchmarking of applications. Let's see. We developed a MIB, an SNMP-like MIB for managing CPU and load on this active network. And that's okay. So what we can do is use NIST mechanism for very large. If you would imagine a denial of service from an attacker over here, he could code very large packets in the sense that they use up a lot of CPU time, or he could also code a stream of very small packets, each one using smaller amounts of CPU time, essentially, or in size. And the idea is that the large CPU packets could be caught easily by the NIST benchmarking technique, and the smaller CPU packets, we could watch the load via AVNMP, because we're predicting what the load should be. And if it exceeds what the load should have been, based on our prediction, then we know that something funny is happening. Either we're not taking something into account, or there's likely an attack going on. But one of our longer-term aims is to, again, get rid of this dichotomy between data and computation inside of a network, or what we think of networks today. And what we want to do is use this active capability to have receptors which identify faults and build up solutions to faults. They solve the fault, and then they disappear, they disintegrate back into the network, so that they don't use up overhead. We are looking at complexity-based methods to do that. I think, this slide shows it a little better. Legacy networks, we look at, for optimization purposes, we always look at bandwidth, which is fairly easy to measure, and based on Shannon type, and using Shannon entropy and compression-type techniques. But we can make a mapping over to active networks, where we should really be in active networks looking at things like Markov complexity, which is the size of the smallest program that can accomplish the same amount of impact that you want to have. oops, I could do the wrong thing. Well, anyway, that was pretty much the last slide. But the point was that there's this mapping between legacy networks and Shannon and entropy and Kolmogorov complexity and active networks that needs to be taken advantage of.
Thank you, Steve.
Okay.
Thank you very much. Time is running fast, but if you have just one short question, we go further to our last speaker, and if there still remains something to the end of the session. Anybody? Now, then let me call Antonio Pinizzotti. The floor. He will present the contribution of Francesco Gennai and Marina Buzzi from Istituto per le Applicazioni Telematiche from Pisa, Italy. Antonio.
Yes.
The title of the presentation is Integrating Security Services with the Automatic Processing of Email Content.
Crashed? It's locked something like that. Can we set? Crashed. Bekle.
So the problem is that the PowerPoint system has crashed here. I don't know why. Do you have an idea? No.
Try to start trying to control.
Did it happen again?
Pardon?
Did it happen again last time?
Happened again.
Yeah.
Geçen sefer de mi böyle oldu? Kim geliyor?
So the computer unless restarted. İçinden mi çıkmıyor? Here's the problem.
Nedir? Kilitliyor, PowerPoint'i açmıyor da. Disket üzerinden.
Yes. I'm copying this file. Okay. That's right. Yes, that's right. Okay. Why? What is? I have two.
Let me save it in our server and
Two versions.
just a minute.
Sorry.
Are there big differences between the new version and the old
Just
version?
some difference, not so much.
And can't you use the old version? You don't know.
Yes, I mean,
Or should we now wait for
it is putting in.
another machine?
He will send it from the server for you.
Yeah, mail server.
He will send it from mail server for you. He sent this from the mail server to your computer. Bu arada çocuklar bir şov yapalım, sıkılmasınlar diye konfon kazıyorum.
Sağ olun.
Biz oynayacağız konfon kazıyorum.
Could you find the original version maybe?
Tek original version, tamam.
Yeah, I use this one.
This is yours?
Yes, but
That's
an updated version. It's okay?
Seems that this purple is corrupted.
Okay. I'm using this one.
So the latest report says that everything will be almost fine, but poor Antonio had to use the earlier version of the slides. Maybe this will cause some problems, but
yes, but there will be just some little difference. I'm sorry because this presentation had to be taken by Francesco Gennai, but he couldn't come here, so I will present it. I'm Antonio Pinizzotto from the same institute, and this work was made by Francesco Gennai and Marina Buzzi. The Telematic Application Institute is an institute of the CNR, that is the Italian National Research Council, and in our institute there is the Registration Authority for Italian top-level domain. Digital signature can be associated with internet messages in order to guarantee authentication, in order to guarantee integrity and no repudiation of the original message. Usually email clients do this on behalf of the user and alerts him in the case there is any problem with the authentication. And this work describes an experience in designing and implementing an automatic system for verification. When email messages, either electronic forms, are used to ask some service from a provider, the automatic processing can speed up data processing, reducing human error as well. In this particular context, signature verification by mail client could become a bottleneck, thus justify an automatic verification system. The particular context for this system is, as I said, the registration authority. So the objective is to automate this verification in order to simplify the registration of internet domain names. The first step of this work was the correct recognition of MIME parts containing protected data. This work is based in two parts. The first part is to recognize how to deal with the MIME part for signature, and the second part the implementation of tools to deal with them. The following RFC are fundamental for the correct recognition of MIME parts, and they are in particular the RFC 1847, that is about secure MIME, and this RFC specifies how to apply security service to MIME body parts, and in this RFC two new content types are added: multipart signed and multipart encrypted. In particular, in this work, the multipart signed is used. The RFC 2630 describes the cryptographic message syntax used to digitally sign, digest, authenticate or encrypt message. And RFC 2633 defines the application PKCS7 signature MIME type used to transport secure MIME signed message, and outline requirements and recommendations for handling of incoming message by receiving agents. The second step was the correct application of the verification process to the extracted MIME paths. And for this purpose, there are two documents mainly. One about mechanisms for certificate retrieval and validation, that is the RFC 2632, that specifies basic rules to be applied by receiving agents in order to correctly verify a signed message, and a framework for managing certificates and the CRLs that are the certificate revocation lists, and it is the Internet draft, Internet X.509 Public Key Infrastructure Certificate and CRL profile, that outlines the format and the semantics of certificates and certificate revocation lists for the Internet public key infrastructure. In particular, procedures are described for processing of certification paths in the Internet environment, that is, how to find on Internet the needed certificates. The tools used to implement the system were a MIME-compliant mail server, and Open SSL toolkit, libraries and application samples. In particular, you can find more information about it on this URL. This is an overview of the system. The system is made by an input process. In the input process we have two kinds of input, faxes and messages, because for registration, for Italian registration authority, you need both faxes and email to ask for a new name domain. The first step in the input process is to store faxes or messages in a database. Faxes are stored as PostScript files, and both for faxes and messages is assigned a global identifier, and this is important to know the exact order in which request arrives for collisions in domain name requests. Now, eventually I'll go back to this figure. Okay, as I said, at the same time, temporary information on the message status is stored in the message status cache, that is in the lower part of the figure, and these status information are useful for greater efficiency of the system. Okay. A message verification process is activated in order to process the new message, as well message already present in the cache database. It means that every time a new message arrives, a new process is activated, but it's possible that a previous message was not processed because, for example, CRL is not updated, so it is waiting for the updated CRL to be processed. In any case, the verification process is activated every period of time that can be configured. The message verification process interacts with the CA database and the CRL database. The CA database is updated by the system manager, while the CRL database is updated by a CRL manager process that will update this database after every period of time that can be configured. When a message is verified for its authentication, it is sent to another process that will send to other process to process the real content of the email. And I think this system is based on the fact that the email is sent with its own certificate for the user who sent the email, and this certificate is verified by the corresponding certificate of the issuer CA, and after it is used to verify the authentication of the email. This slide shows the real message pathway because the system is implemented on a cluster system with 2 nodes. So it's possible that the real order in input could be different in the output of the system because of different time in the processing time. So the output process will reorder the messages because in this particular context is important the order of these messages. And this is just a snapshot on the web-based interface. There are 2 possibilities to log, a privileged and a normal. The normal has just the message fax selection that allows to see the content of the message faxes database, while the other items are allowed just to the system administrator, to the privileged user, and you can add or replace the CA certificate, manage its database, display information about the CRL manager. For example, it's possible that a new download of the new CRL failed, and system configuration where is possible to configure all the policy of the system, and a system monitor, just to monitor. Okay, I finished. I'm sorry, but if you have any question, I think it's better to send an email to the authors, Francesco Giornai and Marina Buzzi.
Thank you very much, Antonio. Just in time, if there are any questions which probably might be answered by Antonio, please pose your questions, but if there are some more complicated ones, then it's better to turn to the authors themselves. Anybody about any other presentations this afternoon? If not, have a good coffee now, and see you tomorrow at 4 o'clock in the afternoon at the second part of this recent results track.